start with just what we do know. All right.
Well, the Earth's axis is presently tilted at about 23.5 degrees from the axis of its orbit.
Okay.
And when it's tilted most toward the sun in the northern hemisphere, that's what we call northern summer.
Okay.
And 6 months later, the axis is what makes the seasons. And because there are astronomical forces that change the tilt of the axis and its orientation over time, the result is climate change. There's 3 cycles that affect the Earth's axis, and they're called the Milankovitch cycles after the man who investigated and calculated them correctly for the first time. His name was Milutin Milankovitch. He was a Serbian applied mathematician and civil engineer. He did this work starting in the 1920s.
Oh, so it's recent. I mean,
It's
recent as the 20th century. Yeah.
People began thinking about how astronomical changes could be responsible for the ice ages long before then, but they didn't really have the details right. He got it right.
So the ice ages were a point of suspicion for historians, why we would go in and out of ice ages without any obvious forcing.
Yes. People wonder what was the cause of the ice ages. Right. Could it be changes in the atmosphere of the Earth? Could it be astronomical forces acting on the Earth? The ice age cycles are, the pacemaker of those are these astronomical cycles that were investigated by Milankovitch. So there's the change in the tilt, which is called the obliquity. The tilt of the axis, which is now 23.5 degrees, that wobbles, that goes through an oscillation of about a degree one way to 23.5 degrees. It goes to 24.5 degrees and to 22.5 degrees, back and forth slowly. There's the change in the direction of the axis in space, which has a 26,000 year period. That's called precession.
So while we're spinning, it will
exactly
wobble like that.
Wobble like that. And the period of that wobble is about 26,000 years with respect to the stars. And the third one is there's a change in the shape of the orbit of the Earth. The orbit of the Earth and of the other planets is not perfectly circular. It's elliptical. It's a distorted circle. And the sun is not in the center of that ellipse. It's off from the center. So at one point in the orbit, called perihelion, the Earth is closest to the sun. 6 months later, it's at the opposite end of the orbit. It's farthest from the sun.